Welcome to the last lesson of Chapter 10, Advanced Swift with Bot. In fact, this is the last lesson of the course. There are three objectives in this lesson. First, you will learn why Swift is such a slow language when you're working with Playground. Second, you will learn how the Apple and Swift engineers send those red marks on the left side of Xcode and tell you what to do. And last, you will learn how to compile Swift using terminal only. I assume you have a very basic understanding of terminal, such as navigating between folders. Well, let's get started. Welcome to Learn Swift About. Today, let's talk about Introduction to Test-Driven Development. Here's a problem statement. Learn how to create safe apps. That's very, very important. Well, before I talk about test-driven development, let's talk about why is it that Swift feels a little slow. For example, when you have 1 to 1,000 or 10,000, when you execute this task, it seems like it's really slow. I mean, the CPU is able to execute about 1 billion calculation per second, but this thing, very, very slow. But why is that so? Well, it's because Swift is actually, there are three ways you can compile Swift into a machine code, machine language. And when you try to, there are three ways to convert it into machine code. One is called on1, slow. Second way. The third way is called unchecked. And right now, okay, I made a typo for you here. So when you run a code in Playground, what's happening is it's compiled into using this on1 methodology. Okay, the speed is very slow, and it's used for debugging. Meaning that we're running in Playground, it's compiled using on1. When you use O, what's happening is it's fast, but that Swift code is compiled to machine language, but machine code, but it's in the release mode. So when you release the app into a bundle, upload in the App Store, it is actually running this O mode. And unchecked is just for testing, for a benchmark. It's not being used unless we set the ecosystem, and we'll try to do that, but it's not being used normally, but we can do that super fast for testing. So let's find out how to do that. Well, we can, first of all, we're going to open up a terminal, and we're going to create, it's called example.swift. Okay, you probably need to know a little bit about terminal. CD desktop, go to desktop, change directory to desktop, CD desktop, and then here we go. We're going to create a file called touch means create a file, touch example.swift. Okay, here we go. We have Swift files available here. Open up, and let's do some execution. So we're gonna run a couple simple lines of code. I'm gonna import I'm gonna just copy paste it, media player, which is gonna be record the duration, how long it took for you to write the code. Let's just copy this. So let's start time, CA current media time. This is live. This is an object, comes along with media player, and you can calculate the this returns a time, okay? And then you run this block of code, and then you get total time is you create another object, and compare with the initial object, and you get the sum is time equals total time, and the print total sum, something like that. So when you want to execute this code, and you can see how long it took for you to execute this file. Okay, save it, and then there are a couple ways to run. First of all, we're gonna run this Swift file using the terminal, and this is a command line you're gonna just memorize or just take a look at the documentation. Call it xcode run. Gonna call it Swift and the compile, and call it again. There are many ways. There are three ways to do it. Right? One is called O. Let's use the O methodology. O. And then you call it example Swift, and then the name of the file, output. The O means output. You're gonna output into, let's call it just example. That's the name of the file you want to output into. So when you run this code, it compiles the Swift, and then it runs an executable file. Click on it, boom, so much faster, right? So much faster than Playground. And here we go, we have 2.6, okay? 2.6, remember that? Let's try to delete this, and let's try to run the code using the uncheck methodology. Unchecked, I believe. Unchecked. Let's try to do that. make a Swift file, run it, boom. Okay, there's now oh, it's just slower. I don't know why. I guess for for simple stuff like this, I guess Allen check is slower. But again, there are many ways the 3 ways to compile Swift code into a machine, compile Swift into machine code, and this is one of the usage. But why do I talk about this? Well, this is important for test-driven development. We'll see why I'm talking about this. By the way, now you know how to run Xcode of Swift files. You can do some tests like tell me the schedule of my day. What are some tasks do I need to do? You can simply write a Swift code and then you can just execute the file, right? I don't know, it's pretty good. Okay, you know how to run Swift file without having to open up Xcode or Playground. That's very nice. Okay, so you might be wondering, why do I even bring up this point? Well, it's very important for the rest of this lesson. Okay, here we go. So what is test-driven development? Well, test development is nothing more than running a test whether anything is valid. Okay, for example, when you do let Bob and they try to print Bob, it's gonna give you an error. This red marks on the left side, right? These are tests. So what's happening is before it is compiled into machine code that the CPU can understand, it goes through a test. See, hey, does the constant Bob has a value associated? If not, throw this error. Okay, break this code, break this computer. Okay, that's what's happening here. We don't see it underneath. But what's happening is whenever you write something, it goes through a test written by the Apple engineers and the Swift engineer. We just don't see it. Just like the enum, right? Enum with code and key, it transpiles and it goes through, it changes and then transform into a machine code. That's what's happening. It runs through a lot of tests underneath the hood that we cannot see. But we as a developer also may need to write a test for it. If somebody using the wrong code, then you want to tell, hey, this is not the right way. This we use this way, or break the code to make sure that the person doesn't make that mistake. Same thing happening here. It's telling us, hey, why not put something to the Bob here so that we can make it work. So, okay, that's what test-driven development. I mean, there's a whole concept about the red light, yellow light, green light. That's a whole different level. Test-driven development is nothing more than writing tests to ensure safety so that you can, if it passes, then that's good to go. That's the fundamental test-driven development. So there are a couple ways to send those error message on the left side. We call it assert. Okay, I'm gonna talk about one by one slowly. I know you might be a little overwhelmed by that, but it's okay. I'm gonna walk you through very very slowly. You've probably seen the fatal error before. We're gonna do all of those soon. So there's one called assert failure, precondition failure, and fatal error. I'm gonna walk you one by one through a couple of examples. Okay, so now, sorry. So let's create a function called enter name. Okay, and you're gonna enter a name here, a string value, and then if name is empty, or you can call it is empty. Let's use is empty. If name is empty, you can say assert condition false. You must enter a full valid name. Okay, and then else if, let's say if name equals Bob, assert false. You cannot use Bob, and then else assert, you can say true. Okay, so this is what's happening. If something is false, okay, when the assert goes false, it's gonna break your program and then send this error message. If it's true, it's simply gonna ignore. So for example, when you enter name and then Bob Lee should be fine. It's gonna go through assert true, nothing happens, all good. But if you either enter Bob, okay, it's gonna say, hey, you see the red mark on the left side? Assertion failed, you cannot use Bob. Okay, you cannot use Bob. So this is what you can you cannot use Bob. This is what's happening underneath. So whenever you run a Swift code, they've written this kind of function or this code for every single implementation. When you use for and load with a switch statement, doesn't really matter. The Apple engineers behind the scene created all kinds of functions. They're so it could be longer than the entire Swift library itself. They write so much. So this code is actually written by the Apple engineers and within using this kind of methodology. Okay. That's why whenever as a programmer, as a user of this language or user of the library, doesn't really matter, I can tell, hey, what was wrong? You cannot use Bob. Okay. Something like that. Test-driven development tells you and guides you through what you need to fix on. Okay? That's what test-driven development is. So you're trying to break something. Yeah. Okay, so that you've learned about assert. Okay? Let's talk about assertion failure. Assertion failure. Here we go. Oh, by the way, just give you another example with, let's say we have an expected result 10, actual result. You can see actual assert, actual result, expected result. If it's true, ignore. If it's false, if they're different, you're gonna return this red mark as well as this message. The actual result doesn't match with the expected. Okay, assert is used everywhere. I use assert all the time when it comes to server development, iOS development, test development. Very, very important, because when you, for example, when you try to access data from the server, and then you want to make sure you get certain data from the server, it has certain number of arrays, certain number of properties, and if that property doesn't exist, you can assert false. Then you know that things are not working right. I'm not going to talk about it yet. So what is assertion failure? What is assert? We talked about assert before. Now let's talk about assertion failure. Assertion failure is nothing more than just simply breaking it. For example, let's create a random number of from 0 to 3. Okay, you random number, and let's create assertion failure random number. Switch if it's case 0, 1, 2. You're gonna print that. But if something else, if anything else, you're gonna assertion failure. Simply failing it, because based on the rule here, when you have arc random uniform, you cannot have anything above 2. Right? If you have above 2, there's something wrong with it. Somebody has changed the code or something has gone wrong. Then you're gonna say, hey, assertion failure, expected index, random number. You can kind of guide you through. Okay, that's what assertion failure is. Okay, so now let's talk about precondition. One by one at a time. Precondition is identical as assert, but here comes the reason why I wanted to study this part. So precondition, actual number, expected number, they look exactly identical as assert, but here's the difference. The difference is that this precondition is also, so when you use assert, when you compile with release into code, into release, when you compile with the release mode, if assert becomes false, it's not gonna break your code. It's simply no, it's not gonna check it, right? But in the release mode, if the precondition returns false, okay, it's gonna break your code. It's not good, because whenever the user is using it, they've encountered some sort of unexpected error. You don't want to break your code, right? You don't want to break your app. You don't want to send those red marks that mean you're breaking your app. So when the user is using it and a precondition true or false, then it's going to break the app. So it's recommended that you use assert instead, because when you use assert, it's only checked within using the debug time. It's not checked during the release time. So assert simply going to be either delete. I'm not sure whether it's deleted or simply ignore. So I don't recommend you to use precondition or precondition failure. Precondition failure is exactly identical as assert failure, but also it is checked during the release mode. Okay, but assertion failure during the release mode, I think the code is probably removed from the entire code base. Okay. That's what's happening, because you don't want to break your app when the user's using it in production mode, in the release mode. Okay, so that's preconditions, and I think precondition failure is the same, but again, just use assertion failure and assert, unless you want to break your code while the user is using your app. Okay, oh good. So what is failure error in failure error? You've probably seen it many times before. This is when you use failure error. Failure error is very similar to assertion failure, but there's a little difference. I'm gonna talk to you the difference here. So let's talk about, so let's create a random number from 0 to 100, okay? And then let's create a function. Let's enter number, return number, and return string value. So you enter string index and return string value, okay? That's the function that you want to work with. So, and here we go. You have a switch statement, index, okay? Let's say if you enter 0, 1, 2, it's going to return the number. Like, yeah, it's a contrived example, but again, if they get 0, 1, 2, you're going to return number with a string value for the purpose of making it work. And then if anything else, let's just do it 2. Let's do it 2. Well, let's do it 3 here, just like the example above. But if there's anything else, you're gonna you could technically say assertion failure like that, okay? But it's gonna give you an error. Why is that so? Because this function must return what? This function must return string value here. But when you use assertion failure, what's happening is it's not returning string value, okay? And also it's not breaking your code, I guess. In order to do that, well, you could also break out of the entire function by calling the function called abort function. That's built in from the library. Called never means it never means well, never means just it's just it never probably never seen that syntax before. It never means you're just executing out of the entire function. Okay, but there's a better way to go about it. Instead of using two functions like that, you could simply use the word failure error. When you use failure error, what's happening is you're simply like breaking your entire app right away. Okay, so you don't have to return anything. Returns nothing. Just breaking it right away from the start. Okay, so what are you complaining about? Let's see. Here we go. Yeah, that's what's happening here. Failure error. Oh, you cannot use Bob. Alright, let's not use Bob. Let's use Bob the developer. Okay, nothing. Should be all good. So this is what test-driven development is. Nothing more than writing a bunch of tests to make sure you get expected result. Okay, if you don't get the expected result, you break down your code. And of course, you cannot write perfect tests for every implementation, right? Test is written by humans. We can miss out some stuff, but at least it provides some sort of safety net. Okay. I mean, in this lesson, usually it was introduction to test development, but I might create a course about test-driven development when Swift and iOS development. Very, very important. Most people in iOS community they don't write tests for it, but I believe I make server, I make apps on my own, right? And I cannot have a bunch of people testing my app, but when I write test using code, it's all automated. All right, I know exactly. This thing worked, this thing happened because I've written tests for it. So again, all I want to tell you guys is that the focus of this chapter was that whenever you write something in Swift, okay, there are a bunch of tests. They're written by the Apple engineers, and whenever before it's compiling to machine code, it goes through a bunch of tests. I've attached a lot of articles for you in the lecture notes. Make sure to go check them out, how those tests are created, and how the Apple engineers check those tests before it is compiled into machine code using LLVM. The Swift founder created that compiler written in C++. He compiles Swift into machine code so that the CPU can understand. But of course, that's very advanced. But I hope you get the point here. Okay, if you did, please thumbs up. It was the last lesson. If you finished this far, let me talk to you a little bit more in the next. There's no next lesson, but in the next video. Boom, you've completed the objectives. First, you've learned the 3 ways to compile Swift files. Second, you've learned how to crash your app, so you're guaranteed that if thing passes, everything's great. However, as the title of this lesson indicates that this is intro to test-driven development, you may join the mailing list on the website and sign up for the next courses down the road if you're interested in learning about more. Since this is the last lesson of this chapter, let me talk to you a little bit more in the next video.